Okay, here we go. C2 rational functions video, finally. Okay, so the first equation is y equals 3x plus 1 over x minus 4. So the first thing I noticed about this function is it's got the same degree on the top and bottom, meaning x has an exponent 1 on both of those x's. So we have the same degree on the top and bottom, so that gives us a hint about our horizontal asymptote. Okay, so if we want to graph this function and state the key features, let's do that. So I'm going to start with finding my roots. So our roots are our x-intercepts, and we know they occur when y is equal to 0. So if I set y equal to 0 in my equation, and then solve this, I notice that if I multiply both sides by x minus 4, then it actually goes away, because when I multiply this side by x minus 4, those cancel out, and when I multiply this side by x minus 4, it will just equal 0. So I get 0 equals 3x plus 1. And then when I isolate x, I get 3x equals negative 1, divide by 3, and I get x is equal to negative 1 over 3. So that's my root, negative 1 over 3. So I'll just make a quick grid here. All right, so if I have to plot the root, negative 1 over 3, negative 0.3, it's going to be here-ish. Let's find the y-intercept next. So if we want to find the y-intercept, now we just have to set x equal to 0. So I just plug that into my equation. So 3 times 0 plus 1 divided by 0 minus 4, and I end up with negative a quarter. So negative 0.25, so that's going to be right there. Okay, next I should find my two asymptotes. So I'm just going to, can I scroll down? I do not know. Yes, I can. All right, so my asymptotes. Let's do our vertical asymptote first. So our vertical asymptote, to find that, we just set our denominator equal to 0. So our equation was 3x plus 1 over x minus 4. Okay, 3x plus 1 over x minus 4. So we're going to set our denominator equal to 0, because we know if that's equal to 0, our graph won't exist, our function won't exist there. So if I set x minus 4 equal to 0, I end up with x equals 4. So I know I'm going to have a vertical asymptote at x equals 4. So 1, 2, 3, 4. So I just do a dashed line there, so I know the graph won't go through there. And then let's find our horizontal asymptote. So if you recall, the horizontal asymptote is when we look at really, really big values of x and really, really small values of x. So if I were to set x as a gigantic number, like 1,000,000, I would get 3 times 1,000,000 plus 1, which is basically 3 million. So I got 3 mil on the top. And then on the bottom, I have 1,000,000 minus 4, which is still pretty much 1,000,000. So I basically have another 1,000,000 on the bottom. And if I divide those, 3 million divided by 1,000,000, I actually just end up with 3 over 1, or just 3. So your horizontal asymptote works out to be your coefficients in front of x, because that's just what happens when x gets really big or really small. So we'd say our horizontal asymptote would be y equals 3 over 1, or just 3. So let's plot that on there. So y equals 3 is our horizontal asymptote. So yeah, whenever you have the same degree on the top and bottom, you can do the coefficients in front of x as your horizontal asymptotes, but as soon as your degree is different on the top or the bottom, then you can't do that. Okay, so then I can kind of tell, since we've graphed 1,000,000 of these, what this graph's going to do. But if you can't tell, you could try subbing values in for x to see what's happening. But I can see these 2 points here, and I know it's going to be approaching the asymptotes. So I know my graph's going to be going like this. because it's going to be approaching my horizontal and my vertical asymptote. And then I know I'm going to have another part of the graph in this diagonal to my other functions, or my other part of the graph. So yeah, there you go. So your graph's kind of split in half there between the asymptotes. So that's an example of one that's got the same degree on the top and bottom. Let's do one that has a different degree. Oh, I see that it doesn't all scroll down together. Cool, let's add a page. Okay, hopefully this is still working. Okay, so let's try a function y equals x, wait, oh, I don't know. Let's just do like a number on top. I don't know. No, okay, let's do 2x over x squared minus x minus 12. Okay, let's say that's our function. So the first thing I notice is the degree is bigger on the bottom than the top, so higher degree on the bottom, which is going to tell me something about my horizontal asymptote. It's no longer going to be the coefficients in front of x. Now my horizontal asymptote, well, if you think about it, if x was 1,000,000, let's talk about really big values of x. So if x was 1,000,000, you'd have like 2 mil on the top. And then if you have 1,000,000 squared, I don't really know, I can't do math in my head, but it would be like a really gigantic number, like way bigger than 2 million. So like so big. And if you divide like a big number by like a massive number, it's gonna approach 0. Try it on your calculator. If you do like 1,000,000 divided by 1,000,000,000, it's gonna be really close to 0. So it turns out our horizontal asymptote is just y equals 0 anytime the degree is higher on the bottom. Cool. Now let's talk vertical asymptote. It's the same way as we did it for the other one. We actually just set our denominator equal to 0. So we don't want the denominator to be 0. We know the function won't exist there, so that's going to create a vertical asymptote. So I see this as a quadratic actually with the squared thing. So I'm going to factor it into 2 brackets. So x minus 4x plus 3. And then I can set each bracket equal to 0 to find my asymptotes. So I get x equals 4 and x equals negative 3. So I actually have 2 asymptotes. All right, so far I found my horizontal asymptote and I've got 2 vertical asymptotes. Let's also find some roots. So I know from the previous one, I just set y equal to 0 to find my roots. And then I also know that my denominator is not going to make any kind of difference at all. So if I multiply both sides by the denominator, it's just going to go away because 0 times that is going to be 0. So I actually just end up with 0 equals 2x. And if I divide both sides by 2, I just get x equals 0. So that's my x-intercept. And then finally, if I want to find my y-intercept, I just set x equal to 0. So 2 times 0 divided by 0 squared minus 0 minus 12. And that's going to equal 0, right? Because 2 times 0 is 0, and then there you go. Okay, so I got all my key features plotted or figured out. Is it like, oh, there we go. Okay, so if I wanted to sketch this graph, let's plot all the key features that we know. Okay, so I know I have a vertical asymptote at 4, 1, 2, 3, 4, and negative 3. And then I have a horizontal asymptote right at 0. So I have to figure out what the heck's happening in each of these sections. So I know I have an x-intercept and a y-intercept right at 0, 0. So that's really the only other point I know. So I don't really know what's going on in any of the other quadrants. So I may have to plug some values in to determine what the heck's going on. Okay, so let's say I wanted to know what's happening over here at 5. So I'm going to sub 5 in. So I get 2 times 5, so 10. Then I get 25 minus 5 is 20, minus 12 is 8. So I get 10 over 8, which is 5 over 4, which is a positive value. So I know it's going to be up here. So I already know this section is going to look like this. Okay, let's say I wanted to know what's happening on the far other side for Oh, I feel like I maybe plotted that wrong. Sorry about that. Was the vertical asymptotes actually -3? My bad. Should have been there. Okay, so let's stick it in -4. So we have 2 times -4, which is -8, divided by -4 squared is 16 minus -4. So that's like +4. So 20 minus 12 is 8. So that would equal -1, I guess, if I did that right. I hope so. So then we plot that there. So that's probably going to look like that. And then in the middle, I feel like I know what it's going to be. I bet it's going to look like that. But if I'm not too sure, I could try subbing some stuff in. Like, what if I subbed in a 1? So 2 times 1 is 2. 1, I'm just subbing it all into this. So 1 squared is 1, minus 1 is 0, minus 12 is -12. And that's just going to be some small negative number. It's going to be here. And then if I did the same thing but tried subbing in -1, 2 times -1, -2. -1 squared is 1 minus -1. So 2 minus 12 is 12. 10. Oh, it's a positive value. So be up here. Okay, cool. So I think it is going to look like a cubic function. Boom. So there you go. That's what it looks like. So that's all of our C2 stuff. Hope that helped.